All right, let's talk about our power grid. It's old, it's fragile, and honestly, it's pretty prone to blackouts. But what if we could build a grid that could actually heal itself? That's what we're digging into today.
Just think about it for a second. A blackout hits, but instead of everything going dark, the grid just intelligently reroutes power. It fixes itself within seconds. Sounds like something out of a sci-fi movie, right? Well, it's a lot closer than you might think.
I mean, we've all seen the news. Massive power failures leaving millions of people in the dark. And it could be caused by anything from crazy weather to just one little line going down. These events really show you just how vulnerable our whole system is. So, to figure out why our grid is so fragile, we actually have to look back in time. Because, believe it or not, the thing that was its biggest strength for 100 years has suddenly become its greatest weakness. Our modern grid was basically forged in this epic battle, the famous War of Currents. You had Thomas Edison on one side, pushing his direct current, or DC. And on the other, you had Nikola Tesla and Westinghouse, who were all in on alternating current, or AC. In the end, as you know, AC won. And that one victory shaped the entire next century of how we get our power.
So the whole system was designed around these absolutely massive physical turbines in huge centralized power plants. We're talking tons and tons of metal spinning constantly. And these things weren't just for making power. Their pure physical mass was the secret sauce that kept the whole grid stable.
Okay, so fast forward to today. The very thing that's supposed to save us from climate change, clean, renewable energy, is creating this huge, totally unexpected problem for the grid.
Yeah, so those giant spinning machines, they provided something called rotational inertia. And the best way to think about it is like a really, really heavy spinning top, you know? It's super hard to knock over, and it just naturally smooths out any little bumps or wobbles. That physical momentum was literally our grid's built-in shock absorber.
And this is where it gets really fascinating when you put them side by side. The old power plants, they're that heavy, stable spinning top. But renewables like solar and wind don't have massive turbines. They use electronic inverters. So they have practically zero physical inertia. We're essentially trading out our heavy, stable top for a super lightweight one that's way, way easier to knock over.
And this is what that looks like in practice. When a fault happens on a grid without that inertia, the frequency just goes nuts. This chaotic, spiky wave you're seeing, that's the electrical equivalent of a total panic attack. And that is what leads to those cascading failures and, ultimately, blackouts. So if we're losing that physical shock absorber, what's the alternative? Well, what if we could replace it with a digital one? An incredibly fast, super smart guardian that's always watching over the grid. And that's exactly what researchers have created. It's an AI algorithm. Now, the official name is the Adaptive Admittance Controller, or AAC for short. But really, all you need to know is its job. It watches the grid in real time and makes these tiny, microscopic adjustments way faster than any human ever could to keep the whole thing stable.
Okay, so remember that chaotic electrical panic attack we just saw? Here it is again. This is what happens to the grid's frequency during a fault when it's left all on its own. A total mess, right? Now get ready to see what happens when the AI steps in.
Okay, now watch this. This is the exact same event, but this time the AI controller is active. Just look at that. Look how fast it tames the chaos and brings the system back to a perfectly stable, flat line. That is the power of real-time, intelligent control. It is literally the self-healing process in action.
So just how good is it? Well, on average, this AI slashes those dangerous frequency swings by a whopping 53%. That is a huge, huge leap in stability.
But wait, here's the part that's a total game changer. The AI didn't just stabilize the grid, it also figured out the absolute most efficient way to do it. It realized, hey, we don't need to put these expensive regulators on all 114 lines. We only need them on 5 critical ones. That single insight cuts the cost of doing this by over 95%. It's not just smart, it's practically genius.
All right, so the AI can act as the grid's lightning-fast brain. But, a brain needs a body. So what does a more resilient physical grid actually look like?
And that's where microgrids come into the picture. A microgrid is basically what it sounds like. A small, local energy grid with its own power sources. It can be for a hospital, a neighborhood, a big data center, and it can operate all by itself.
So here's the magic of how it works. First, it generates its own local power, usually from solar or wind. Second, it stores any extra energy in batteries. Third, and this is the really cool part, it can completely disconnect from the main grid during a blackout. That's called islanding. And what that means is, fourth, it can keep all the critical stuff running no matter what's happening on the main grid.
And you know what? There's another huge benefit here. When you send power over hundreds of miles of wires, you lose a surprising amount of it, somewhere between 8 and 15%. Just gone. Poof. But by generating power right where it's being used, microgrids basically eliminate that waste. They're just flat out more efficient. Okay, so we've got an intelligent AI brain, and we've got a resilient body made of these microgrids. So what happens when you finally put the two together? Well, you get the blueprint for a truly self-healing grid. The AI acts like the central nervous system, right? Making these split-second decisions to keep the whole network stable. And at the same time, the microgrids are like independent cells in the body. They can protect themselves and keep functioning even if the main system gets hurt.
The researchers who developed this AI, they put it perfectly. They said this could be the very foundation for future grids that are self-optimizing, where these smart algorithms are just autonomously maintaining stability. The grid isn't just a passive bunch of wires anymore. It becomes this living, intelligent system that actively keeps itself running, no matter what you throw at it.
And that really leaves us with one last big thought. The core idea here, using AI to manage the flow in a really complex network to prevent it from crashing, that's a universal concept. So if it can learn to heal our power grid, what other crazy complex systems, from city traffic to our global supply chains, could it learn to heal next?